So I'm using that basic formula that they show us on page 266, where you have the general form of a log equation being the stretch factor times the log of x minus h, where that's the vertical shift, or the horizontal shift, if there's any, plus k. So for this graph, I'm seeing a vertical asymptote of x equals 2 instead of the y-axis. So that tells me it's been shifted to the right too. So I'm going to write x minus 2 plus k. Now I don't know about the vertical stretch, but I do a vertical shift, but I do see some, I see this point here, 1, -1. Oh, the other thing I'm noticing here as I'm talking, that instead of heading off this way, it's been reflected around the y-axis. So that tells me that I should stick a negative inside here. So now let's substitute in 1, -1. So I know y is -1. That equals a times the log of negative, well, let's see, 1 minus -2 is, or 1 minus 2 is -1, but that negative changes to a positive, plus k, and the log of 1 is 0, so that all cancels out. So that tells me this graph has been shifted down 1. So at this point, I have a times the log of negative x minus 2 minus 1. Now maybe it's time to use one of these other points, and that one looks much more tame than the other one. So 3 equals a times the log of negative, well, let's see, -3 minus 2 is -5 minus 1. So 3 equals a times the log of 5 minus 1. I'm going to add 1, get 4. Equals a log 5. So that tells me the a factor is 4 over log 5. And I'm pretty sure that's the answer. I could check another point. Do I see one that's handy? I don't want to use that y-intercept. I'm not seeing one. We could go graph it and check.